So hello everyone, thanks again for joining me today. So this is the second part of my presentation. Actually, I did another lightning talk nearly 1 year ago. This was about like promises and how do we run promises in the background, how to JavaScript execute code in the background. And now I'm going to show how this is happening with async await actually. Like this is the most cool and the new technology of the JavaScript. So this is the second part. Before starting, I will do a small recap for people who didn't watch the first one so that we will be on the same page and we can start on the async await without knowing the core stuff from promises. So there is this question: is JavaScript asynchronous or synchronous? The thing is, lots of people think that JavaScript is an asynchronous language which has multi-threads, but actually this is not true. It has just one thread, and we can execute just one code in one time. The people are thinking that it's asynchronous because we can do lots of stuff in the same time with JavaScript. Like we can fetch some data, we can do some rendering, we can, I don't know, maybe do some hover effect, like lots of stuff. So how can we do this with one thread? Actually, uh, we are not using one thread. Since we are running our code in the browser, browser is helping us while we are fetching some data and doing some asynchronous tasks. There are some browser features that we are using, like XHR or timer or other stuff. These are running some tasks in the background so that we can run our other tasks while we are waiting for our requests to resolve. But let's think that we could only fetch data synchronously with just one thread, and we couldn't do uh, multitask at one time. So it would be really bad for users that will use our website, because the thing is, if you are going to wait for the response of the request that you sent, let's say that it will last for 200 milliseconds. User cannot do anything for 200 milliseconds. The web page will be blocked, and like you cannot even click on a button. And how it would look like. So this is a performance test that I took, which was not using any synchronous requests. As you can see here, like you need to focus on those tiny and thin lines. These are actually representing, each of them are representing some tasks that we do. And as you can see, there are tons of tasks that we run. And these are taking so small time so that it's just getting inside of the thread. It's using the thread, doing its thing, and then leaving it to other functions. And the other functions are using it. So with doing it like that, uh, it's not, we are not seeing the browser getting like frozen anytime, and everything is working pretty fine without any looking frozen view. But if we just had option to send synchronous requests, it would be looking something like this. So we will do some tasks here, and then we would start fetching some data. But if this data takes more than, I don't know, 200 milliseconds or more than 10 milliseconds, it would look something like this. In this meantime, we cannot do anything else, and this will block everything in the browser. This is not what we want. That's why asynchronous features of browser are so important for us. So before starting to run my code snippets, we need some rules so that we can run the code snippets line by line, just like JavaScript does. So JavaScript is a single-thread language. We already talked about this. We can do just one thing in one time. We can just execute one line of code. We will try to keep call stack clear as much as possible. So call stack is basically representing the thread. So if you have some stuff in the call stack, you will need to finish those stuff as quickly as possible so that you can take other ones. We have this third one. This is call stack is paired on both callback queue and market test queue. These queues, I will come to those in a second in the next slides. These queues are actually some queues for our tasks that we want to push in the call stack that we want to execute. But these will come from browser features like timer or XHR. So we will place them to some queues, but since call stack is prior than those queues, we will execute our stuff inside of the call stack, and then we will take some stuff from here. Okay, the last information before starting executing my code snippets, I want to show you the execution context. What is the execution context? So here you can see we have a global execution context in here. The whole code is called global execution context. But here you can see some other execution context, like called functional execution context. So behind those curly braces, we are getting inside of the functional execution context, and we can do just things inside of it until we finish it. We cannot get outside of it unless it's a special function or something like that, something like generators. And I will come to that in the slides. So no, oh, we need to wait for 1 second because this is actually the first presentation that I made. Yes, this is the correct one. Perfect. This is the first code snippet that we are going to use. So let's check it out in a brief way. So we have a function which is called custom iterator. It's actually a example of iterators. And this iterator is getting an array. Default value will be an empty array. And we have our index, which is equal to 0 initially. We are defining a function called next. This will calculate the current element, and then it will increase the index. And then it will basically return the current element. At the end of the function, we are returning an object, and this object is including the function that we defined just now. After this function, as we can see here, we are defining a variable called custom iterator. We are calling it with an array, and then we are running array_iterator.next. So we hope that each time we run this line, we will get value from this array, like 2, 4, 5 in an order. So let's start running our code. So let me also introduce you this view that I made here. So we have a time here. This is not an actual time. This is just here to keep the track of time and like to see the differences, like to see the order that we execute our codes. And here is a small message that I will show every slide, so that people who will watch it or check the slides afterwards can get a summary of the whole step that we are doing. So we have our console here. Console is basically the console that we have in our browser's DevTools. We have our call stack. This call stack is a stack that I just mentioned to you before. This is a last in first out stack. So if we are going to push something inside of it, we need to execute this and finish it first so that we can continue the other stuff. This is basically the thread that we have. This is some kind of like a notepad for me so that I can run lines here. Here we have our browser tasks section. So we will run some browser tasks here, like XHR or timer. Here we have our memory of the browser. We have our queues in here, and so on. So final thing, we have this red mark here. This red mark will show us, a red bullet will show us which line we are executing right now. So let's start with it. In the first thing that we will do in first millisecond, we are defining this function called custom iterator, and we are putting it inside of the memory. Then we will continue working on in the next lines. But you can think that we will execute this line. Actually, no, we are not going to execute this line because this is a functional execution context. So we are not getting inside of it until we call this function. Since it's not being called yet, we will continue working on our global execution context, and we will come to this line. And in this line, we are defining a variable called array_iterator. Its value will be undefined initially until we calculate the right side of this equation. But once we calculate it, we will assign it to the array_iterator. So here we are calling custom iterator function. We will jump to the custom iterator function execution context, and we will push something to call stack. So here we push something to call stack. Right now we have another stuff on top of global execution context. So since we have another thing, we cannot continue executing those lines. We need to finish this function as soon as possible to return executing those lines. Until then, we are blocked. So I created the execution context inside of here. Initially, since we passed a 245 array to custom iterator as parameter, array's value will be 245, and in the first line, we are defining index equal to 0. In the next line, we are defining function called next. We are not getting inside until we are calling it, so we are just skipping to the return section. In the return section, since we got into the return section, we are going to remove the execution context of this part, and the values that we define here, they are going to be garbage collected automatically by the JavaScript. We are not removing all of those, but we cannot reach it anymore. We can reach it, but I will show you in a second. We cannot reach it in a normal way since it's being garbage collected, and this execution context is completely gone. Now we will return this next value, and we will assign it to the array iterator. And the array iterator's value will be next. But here you can see that there is a weird thing in here. It's square bracket, environment, square bracket, square bracket. So this is actually what it's called closure in JavaScript. So closure is the thing that, so when you're defining a function in somewhere, it will get a copy of the data that it has in his surroundings. So here, when you are defining this next function, since you defined this index and you defined this array's value in here, you will have a copy of those data, and in its closure, this next function will always have access to those things. We cannot return to custom iterator's execution context because it's all gone until we call it again. But since this function is being defined inside of it, it will have access to some properties, and this is closure. Now we will continue running our code. We are running our first console log. It will call arrayiterator.next. So arrayiterator is defined in our memory. As we can see, it's an object and it has a next function. And when we call this next function, we will get inside of here. So we will create this execution context here. And this execution context is, in its first line, it's defining a variable called current element. So this current element's value will be undefined initially, but since we have this array and index, I didn't write down undefined. And right now, we are directly calling array and index. But as you can see in here, the execution context of this array iterator.next, we don't have the array, the value of the array. We don't have the value of the index. And when we go to the global memory, we don't have a value called array and index. So how can it reach it? It can reach it through this environment, actually, this closure, because it has access to those values inside of its some kind of like backpack. It has those values inside of it. So it can modify those values and it can read those values without a problem. That's why it's not giving any error. So we can calculate it in that way. We have our array equal to 245 and our index will be 0. So since we are getting the first element of this array, our current element will be equal to 2. We will increase the index. This index will be increased inside of the backpack. And then we are going to return the current element, which is 2. And in the 9th millisecond, we are giving our first console output, which is 2. We will continue doing this again and again for 2 times, and we will call arrayiterator.next. It will do the same thing. It will just create the execution context of this function, and then it will run code line by line. Since it has the index inside of its backpack, it was updated before. It was increased to 1, and so it will start from 1 this time, and it will get second element of the array that we pass to this function that it has in its backpack. So this will be 4 this time, and the next time it will be 5. So this is the basic version of iterators. So the thing is, what this is helping with us, we could have done this with basically a for each loop, or just a basic for loop. We can just run a for loop inside on top of this, and we can console log all of those values one by one. But the difference here is when you are running a for loop for this one, you are starting from the beginning and you are going to until the end, and you cannot do anything else in the meanwhile. So let's say that you have an array which has a million numbers inside of it. So until you finish all of those stuff, you cannot do anything else. But here you can see that we are calling it whenever we need it. So I'm calling it here. I got the number 2. I can do some stuff in between those lines. I could have done this, and I can return it back to it anytime I want. I will call it again. I will call it irritator.next, and I will get 4 this time. So this is like giving us ability to do some tasks in asynchronous way. It's like not in asynchronous way, but like you can split things in to small tasks. This is a really powerful thing, actually. So this is my second code snippet. This second code snippet will include some generators. The first one includes iterators. By the way, I have 3 code snippets in total, actually. And the first one was the hardest one. The second one will be a hard one, and the third one will be an easy one, because like we are going to see async await in the third code snippet, and we are just seeing how things are kind of like imagined before like building those stuff, I guess. And we are just like going to go to the easier way to do those, to the modern way of doing those. But first, let's see the background. Let's see what's happening without those cool stuff that we have. So here we have a function defined here. It says it's going to print the data according to its name. It's calling some kind of like data iterator.next. I don't know what that is. We don't define it yet. So let's continue with the next function. It's a generator function. It's called fetch data. It's defining a data variable. It's using this yield keyword, and it's starting to fetch some resource from internet. It can be any link here. But I put this localhost link here because, like, let's say I said that, okay, let's imagine that you have an API, you have an endpoint in your local machine, and it will respond to you in 200 milliseconds, and it will give you some text string as a response. So we can imagine it in this way. We don't need another outsourced API. And after fetching this data, we will console log this data. And this will be the end of this function. And here we are defining a variable called data iterator. It will call the fetch data generator function. Here we are defining a fetch data variable. It will call data iterator.next, just like the one that we have in the iterators. And then we are using a fetch data.then method to print some data. Like we are pushing this print data function inside of this promise, most probably because promises have this then method of it. So let's see. In the first line, we are defining the print data function here in the memory. We are not getting inside. We are completely skipping the lines that it has inside of it, and we are continuing to the second function. It's called fetch data. We are defining it inside of the memory. If we are not getting inside, we are going to run the data iterator, which is inside of the global execution context. So data iterator is being defined. The right-hand side is calling the fetch data function. This is a generator function. So since this is a generator function, it will return us this value, actually, this object, which has a function called next inside of it. So the data iterator variable that we set here will be equal to this object, since we are running a generator function. And now we can continue working on our next line. This is defining a fetch data variable. It's equal to data iterator.next. Let's see if we have data iterator.next. We have data iterator defined here. Next is also defined here. So we will create this function execution context, and we will push it inside of the call stack. Since we have it here, we cannot run global. We will need to finish it first. So data iterator.next will be equal to this generator function's body, actually. So we will continue running this fetch data function, and we will get into the first line. So the first line is actually defining a variable called data. It's defining inside of the local memory. It will be undefined first. Let's check the right-hand side. This right-hand side has this keyword called yield, which is super powerful, and it's calling a fetch request. So this fetch request is doing 2 things. If you watch the first episode, you will know what it's doing. The first thing that it will do, it will create a promise in the JavaScript side. And it will start fetching a request in the browser side. And how do we show the browser side? So here you can see that I'm using this browser task section. So we call this XHR request. And this XHR request will be initially unresolved because like it will take 200 milliseconds, as we just agreed in the beginning of the slide. And browser will handle this request for us. In the meantime, we can continue running our code. It's not a blockage for us. So now browser will start to run request, and in JavaScript side, we created a promise here. And this yield function, this yield keyword, it will immediately push us out of this fetch data function. And it will return this the value of that it has on the right side of it. And it will pause this function until we return back to it. So the things that I told you before, when we start to run a function, we need to finish it until until we run the other stuff in the call stack, like the other execution contexts. But we cannot, we are not doing this since this is a generator function, and since we are using this yield, we have this access to return back to this execution context. So we are just skipping it this time, and we are getting outside. So fetch data, we call this function. So fetch data's right-hand side will be equal to a promise that we generated just from here, like 1 second ago. So fetch data will be equal to a promise, and this promise is basically have some fields. It's called it has a status field. It will have a value which is undefined initially. Until we fetch the data, it will be undefined. It has an array called all fulfillment array. So these fields are actually like the fields which are the most important things in our promise. So it's whenever our XHR request is being solved, like whenever it has the check mark at the end of the 200 milliseconds, the value of this promise will be updated. And when the promise's value will be updated, the things that we have inside of the fulfillment array will be pushed to the microtest queue so that we can take them inside of the call stack. Now, since we don't have the value updated, we're still waiting for the response, and since we don't have anything inside of it, we can continue our execution in the global execution context, since we have another line inside of it. And when we go there, we are running a method called then of fetch data. So fetch data was a promise that we defined. So this promise has a then method also. With this then method, we are actually passing a function to the on fulfillment array. It's just taking a function and it's putting inside of the on fulfillment array. And at the end of this fetch, we will update the value of the promise, and we will push this inside of the microtest queue. So here you can see that it's still unresolved, but I put this print data to onComplete. Actually, in onComplete, we are not going to run print data. We are going to update the value of it. And we will, since we will have a value, we will push those inside of the microtest queue. So this is some kind of like a after step of it, but I didn't want to like write down fetch data dot value is equal to the fetch data that we fetch. Like I just put print data to here because it's also kind of the same thing. So right now we have our request being processed in the background. We have our on fulfillment array field. We have one task to do. So we can continue our global execution context, but we don't have anything else left here. So we can remove it also. We don't have anything else. So we will wait until the request resolves. And at 250 milliseconds, the request will be resolved. And now we are ready to push things inside of the on fulfillment array because value is updated to the data that we fetched. Now the things that on fulfillment array has, we are inside of microtest queue. And since we don't have anything inside of the call stack, we will directly push this print data to the call stack, and we will start to execute this code. So here you can see that we are calling the print data with the value that we fetched. The value that we fetched is nary. It's equal to nary, and we are calling the print data execution context with this value. So in the first line, we are putting this value to the memory of the local execution context, and then we are continuing to the second line. The second line is calling data iterator.next with the value that we have in our local memory. So we don't have data iterator here. We are checking out the global one. We have data iterator here. It has this next function. And with this next function, we are actually getting back inside of the generator function that we skipped. So we skipped here actually. We just run this yield fetch function and we didn't even assign the value of data inside of it. Now we will return back to it and we will assign the data that we fetched to the data variable that we have in the fetch data generator function. And we will continue, since we have this one, this data inside of here, and since we finished executing this line, now we can continue in the second line. Since there is nothing, no yield keyword left we can continue running our function just like a normal function. And we are now running the console log data, which is equal to nary, and we will give our first console output in the 290 milliseconds. And since we are coming to the closing curly brace, we are removing the execution context, we are removing it from call stack, we will return back to print data, we are doing the same thing for that, and we don't have anything else left for this code snippet, and it's finished. So this was the example of generator functions actually. Now we will jump to the async await, which is the most latest one, and we will see how things are automatized, like happening much more automatically without our touch. So here you can see that like I'm pushing some functionality to those promises. I'm like calling the next and the other stuff, but with the async await, I'm not going to need any of those. JavaScript will do those automatically for me. So let's check our last code snippet. So here we have our async function, which is defined with the async keyword. It's a function which is going to fetch some data, and then it's going to return this data. Like it's not going to return. It's going to console log this data actually. And instead of yield, we are using this await keyword here. So other than that, we have this console log here. We are calling this function that we defined, and then we have the last console output here. Let's start executing this one. So here you can see that I have this fetch and print data function defined in the memory. I'm not getting inside. I'm continuing on the global execution context. And here I have this console log here, and we are giving our first console output in the first millisecond. Now we are calling the async function that we defined. I'm creating an execution context here. I pushed it inside of the call stack. Now we will start working on this. Fetch data, the left-hand side of this equation will be set to memory. It will be undefined initially, and then we will go to the right-hand side. We will see the await, and since we have the await, we know that we will just jump out of the function and we will skip it for a while. But let's run the code on the right-hand side. It's going to run a fetch request, and this will trigger a browser action, which is an XHR feature of the browser, and it will start fetching some data from this endpoint. But since we have this await, we will get outside of the function and we will skip it for a while. And the difference between the last snippet and this snippet, as you can see, right now in onComplete, we have a thing to do actually. We don't define what we are going to do. JavaScript is automatically doing this for us. So whenever we finish this fetch, we will return back to this function and we will continue running those stuff if we have an empty call stack. So if we have some stuff in the call stack, we will wait for a while until the call stack is finished. Now, since we have this await, we have our request running, we can get outside of the function, we can continue running our other stuff. This is the console log that we have in the last line. It is giving a console output in the 5th millisecond. We still have our request not resolved. We started that in the 4th millisecond, so it will continue until the 204 milliseconds. In the 6th millisecond, since we don't have anything left, I'm removing the global one here. Call stack will be free. In the 204 milliseconds, our request will be resolved and fetch and print data will be ready to run. Since there's nothing inside of the call stack, we are just pushing it inside of the call stack, and we are continuing our task from the line that we paused, and we will continue executing the function that we skipped for a while. So fetch data was undefined before. Now we have the value which is equal to nary. Let's say that nary came from this endpoint, and the value of the fetch data will be equal to nary. In the next line, we are running the console log fetch data, and with this console log, we are giving our last console output in 206 milliseconds, and this will be our last console log. With the ending curly brace, we will remove this from call stack, and we will terminate the execution context of it. And this is actually the end of my last snippet. Whew, okay, it was I don't know. I hope it was a quick one. Sorry if I made it a bit longer than that. If anyone have any questions, I'm open to those.